This mini-split air conditioner circuit board is showing an F1 error code. Let me explain the main problem that the company has mentioned. According to the company, this error occurs due to the IPM, and I have already made a video on how to test the IPM. The LED light is turning on very late after it's powered on, and here you go, the LED is turned on. The problem could be due to a short circuit, which is why the LED light turned on late. Now, let's test the IPM because faults often occur in the IPM. First, we will check the high side of the IPM. As you can see, 322 volts are coming through. Next, we check the voltage here, and it's 14.62 volts. The same voltage is present at the next point, and even at the final point, the voltage is almost the same. So looking at this, the IPM seems to be perfectly fine at the moment. However, despite this, the F1 error is still showing up. I should also mention that this PCB is used in various brands. As you can see, there are two ICs, IC1 and IC4, both of which are operational amplifiers. I have another PCB available, and I'll show you where these ICs are located on it. Here, you'll notice a shunt resistor that is used for current sensing and protection. If there's an issue, this resistor will blow. We need to check whether this resistor is working correctly. Regarding IC1, its calculations are happening on channel number 1, so we will check the output to ensure the calculations are correct. Additionally, there's a second channel inside it, channel number 2, which also needs to be checked. Now, as you can see, there is another shunt resistor. This is the shunt resistor we need to focus on. First, the electric current is coming directly from here. One point of the shunt resistor goes to the emitter of the IGBT. These 2 points are connected to resistance numbers 75 and 76. Then, the emitter point also connects to this resistance, and there's a diode connected here. From the diode, the current flows directly to the non-inverting pin, creating a loop. The output is then taken from this point as well, for channel number 2. Now, there are 2 more resistors installed here. These resistors are connected to calculate the points coming from the bridge rectifier. Through these 2 resistors, the current flows to the capacitor, and after that, there are 2 more resistors of 510 ohms each. These resistors connect to pins 2 and 3, which are the non-inverting and inverting pins respectively. Both points lead to pin 1 of this IC, where the output from the shunt resistor is received. Additionally, the second channel of this IC is also used. This circuit is responsible for calculating the high DC voltages. It's a voltage limiting circuit, so if there's any issue with the voltage, this circuit detects the problem and informs the microcontroller, which then signals the system to shut down. This setup is crucial in protecting the system and ensuring the correct operation of the voltage calculations. There are 3 470 kiloohms resistors installed on the negative, positive points. Through these resistors, the current flows to the capacitors. After that, there are 2 1 kiloohms resistors, which are connected to the negative and positive sides. Following this, there are capacitors, and then diodes are installed. These diodes are used to stabilize the voltages. The voltage passes through these components and reaches pins 4 and 5 of the IC. Pin 4 is the non-inverting pin, and pin 5 is the inverting pin. Pin 7 is where the output is obtained from. This entire setup plays a crucial role in maintaining stable voltages and ensuring the proper functioning of the circuit. Now, I will provide electricity again and check the voltages to identify where the problem lies. As you can see, the lights are now on and the PCB has switched on. Next, let's check IC number 4. First, we will check its output. The output pin is pin number 1. We can take the ground from anywhere. When checking pin 1, it shows 2.497 volts, which is perfectly fine, so there is no issue here. After that, let's check the output at pin 7. It shows 2.51 volts, which is also correct. Ideally, it should vary a little. If it varies, it would be even better, but for now, it's fine. Next, we check pin number 1 again for the voltage. It shows 15 volts, meaning this IC is almost fine. Now let me explain what often goes wrong in this situation. Sometimes the resistors go bad, especially the ones in this circuit. Faulty 510 ohm resistors, issues with the 1 kiloohm resistors. These can also fail, causing voltage problems. The operational amplifier itself can fail, which may be the root cause. Now, let's check the voltages for the next operational amplifier and see if everything is working properly. First, the output pin for this IC is pin number 1. After taking ground, I checked pin number 1 and it shows 2.634 volts, which is perfectly fine. This means the shunt resistance is being calculated correctly and the output is being sent to the microcontroller accurately with no issues. Next, let's check channel number 2. Checking pin number 8, it shows 5 volts, which is correct. Then I checked pin number 7. There is another resistor connected here, and it should also show 5 volts. Pin number 4, I should have seen 2.5 volts, but it's not showing up. When checking the positive side of the capacitor, it showed 6 volts, which is incorrect. This indicates 2 possible issues. One of the resistors may be faulty. The diode or operational amplifier might be faulty. Based on these findings, it seems that either a resistor or the operational amplifier could be the cause of the issue. Now, let me show you another problem. If you noticed earlier, when I applied power, this IPM was outputting around 220 to 250 volts, which wasn't correct. To investigate further, we'll test the IPM in diode mode without electricity. This is a reliable method. When checking the diodes in the IPM, they are showing 0, which they should not be showing under any circumstances. When I connect the negative probe to the negative terminal and the positive probe to the positive terminal, it indicates that there is internal leakage in the IPM. Now, after reversing the polarity and testing, it shows some voltage on the next point, which is correct. The second and third points also display correct values. However, the first point is showing 0, which is incorrect and indicates a problem. This suggests 2 possibilities. The IPM could be faulty on the high side. We have IC number 1, which is a 2302, and IC number 4, an LN258. Both are operational amplifiers, so if there is an issue with either, it might be affecting the system's performance. In the first step, I'll replace the IPM to ensure the correct voltages are present. After that, if the issue persists, I'll proceed to replace IC1, the operational amplifier. However, changing the IPM is the priority in the first step, followed by the IC if needed. The IPM is now removed, and we'll check it again without applying any power to the board. First, we check it with positive polarity, and nothing appears. After changing the polarity, we see some voltage showing up, which indicates some response. The next 2 points show no values, but the fourth point does show a value. When we check with the second point, all points on the IPM show the correct values. The third point also shows the correct values, which means the IPM is showing correct behavior overall. Now that I've replaced the IPM, I mounted it with the heatsink and soldered it properly. This way, there is no gap between the heatsink and the IPM, which helps reduce the chances of the IPM overheating. After connecting the power and completing the wiring, I checked the system again to see if there was any change. However, the lights are still turning on in the same way, and after about 10 to 12 seconds, the system turns on. The LEDs 1 and 2 are continuously blinking, which indicates an F1 error. This suggests that the issue persists despite changing the IPM. Now, our next step is to replace the operational amplifier IC1 as it's not functioning properly. The issue is that the voltage on channel 1 is not coming through. It should have 5 volts, but it's not showing up. So, I have removed the faulty operational amplifier from the PCB. After removing it, I cleaned the area thoroughly. Now, the PCB is fully fixed. Let me explain what I did to resolve the issue. I replaced the operational amplifier, but the voltages were still not coming through. Upon further inspection, I found that 2 resistors were not functioning properly, and they were also varying in resistance. Additionally, a 10 kilo ohm resistor was also varying, so I replaced that as well. After changing these components, the system is now working perfectly. I have powered on the PCB, and after a while, it turned on. The lights came on and then turned off, and the error that was previously blinking is now gone. The blinking lights are no longer appearing. Now, let me show you the voltages. I connected the ground and checked pin number 7, where 5 volts are present. Then, I checked the non-inverting pin, where 2.12 volts are showing, and on the inverting pin, I found 2.63 volts. These voltages combined are providing a stable 5 volts at the output. The PCB is now fully functional. Click on the left or right thumbnail to watch our next videos and subscribe. Thank you.